Hey everyone, I'm Vilde. I work for SoundCloud, as you just heard, and I'm here to talk to you about something that I've called migrations under production load. How to change your database without disrupting service, which I hope you are all also interested in doing. I'm going to present a four-phase approach to how to change your production system without changing your production behavior. And I'll use two real-world examples of projects that I've worked on in order to illustrate how these happen. One is a project that was supposed to be small and ended up being quite long. And another is a project that we knew was going to be long and went better than we had expected. So to introduce myself, this is my first time here at SREcon, and it's also my first time ever speaking at a conference. So I'm very excited. I'm from Norway originally. I went to university in California. I did a bachelor, something called Symbolic Systems at Stanford. And I moved to Berlin in 2015. I've lived there for 3 years now. And 2 years ago, I started working at SoundCloud as a backend application developer. And I'm actually moving to front end in the fall, but I'm still a backend developer right now. OK, so let's get started. Before we get into it, I want to talk about what I actually mean by a migration. So I'm intentionally a bit fuzzy here because these projects will depend a lot on your situation, your business, your technology. But what I mean by a migration is a change in architecture without a change in behavior. So I'm not talking about an alter table type of migration. And I'm also not making any kind of comments about what kinds of databases you should use. I will mention a couple of different database technologies in this talk, but the talk is about the approach and the mindset and not really about the individual databases. So yeah, this is a strategy for how to approach these projects and making sense of your needs in the different phases based on my own experience. The phases I'm talking about are these. There are 4 phases with a secret phase at the beginning. That's actually very important. So the first phase is to justify your migration. The reason that this is important is that these projects are, as all projects, but are very often underestimated. And so you need a better reason to migrate than you think at the beginning, in my experience. And after you've justified your migration, you start by setting up the writing. After that, you move on to comparing, where you look at the correctness of your data, either by comparing results in process or setting up some sort of external system to compare results. After that, you optimize or productionize, or you can call this different things, where you roll out the new solution at a pace that you can handle. Sometimes that's 100% immediately. Sometimes that's very carefully, depending on your needs. And you optimize until you reach your goals in terms of latency and other factors that you need. After that, there's another phase that ends up usually being the longest one, where you wait until you trust the system and until you can clean up the old system. And there's a lot of surprising things that come up here that you might not consider in the beginning, like metrics, analytics, documentations, habits, shortcuts, and old hacks. So there can be a lot of surprises in the waiting phase as well. You'll see in the examples that the phase boundaries are not always exactly discrete, but they do, at least for me, it's been very useful to think in these phases in order to focus on what my real needs are at that moment. And you'll see that you have different needs in the different phases. So the first project, The first project that I want to talk to you about is something I called a feed migration. Here's a simple diagram of what the system looks like. I've intentionally excluded a lot of detail because they're not what's important here, but the system, there's an upstream system, and we have this system that pulls references from the upstream system and stores them in a Cassandra database. Cassandra is a key value store, NoSQL database, and then exposes search results over those references. And our goal from product was to migrate a feed, so this system has several feeds for different partners, migrate one of the feeds to a different data set with a new catalog of data. And then with small parentheses that this new feed would be delivered through a totally new write path. So it would no longer be polling, but event-based. But at the beginning of the project, this was only a small detail, and we were just supposed to migrate the feed to a new data set. And then we thought we had an opportunity to clean up stale data. Because of the data model of the system, we don't support deletions from Cassandra. So once something is in Cassandra, it will be there forever. But we handle deletions in the upstream system, where we later on go back to the upstream system and ask, has this been deleted or not? So this means that we have a lot of stale data in the database, and we thought we would take this opportunity to get rid of it by recreating the whole database and starting over. And we also thought that we would take the opportunity to upgrade the hardware. Cassandra is, at least our setup is self-hosted, so in order to upgrade the hardware, we needed to recreate the cluster. Okay, so when this is the justification where we wanted to move. We had this product need, and we wanted to just migrate this feed to the new data set. So we got started, and we set up the writing. We started with setting up a new cluster and hooking it up to the new write path, so no longer the polling. And everything seemed to go okay. We moved on to the comparison stage once we had some writing set up. Because we had no code changes on the read path, so here the data model is exactly the same, it's just the data that's different. So we have no code changes on the read path. We didn't really need to test anything but the data. But we didn't have a way to directly compare the data in the databases because the data set is different. So we set up a second application that was connected to the new database and then used an external program to query both and compare. Here we actually spent a lot of time in the comparison phase. This project was scheduled to take maybe a month, maybe two, and ended up taking way longer because we stumbled on a bunch of problems here. First, we had a weird hardware degradation issue, so we actually needed to recreate the whole cluster again, which takes a long time because we're working with physical machines. Then we found, after we started comparing, we found an issue with the data delivered from the upstream, where they actually needed to redeliver everything once again. And when we did the backfill, there was also an issue with how the backfill was done. So we ended up just wasting a lot of time trying to fix this. And in the beginning, we were told that we wanted to migrate this feed into a different data set. And then, just as a side note, change the delivery method. And after we'd done all this work, and finally were able to compare and get correct results, we discovered that actually this is not a change in the data sets, it's a Kafka integration. We're changing the right path, and this is actually migration, which we had not recognized until this moment. And then we discovered that the data had actually been duplicated anyway. So all of the data was in both the old system and in the new system. And except for the hardware upgrade, all of the work that we'd done to get rid of the stale data was unnecessary or ended up being a waste of time. So looking back, if I had gotten this project again, I wouldn't have done a migration at all. It would have changed the writing integration and left the database alone. And then if we found that we had hardware issues, we would tackle that separately. Because this project was supposed to be and thought to be small and ended up being quite large for what I would call unclear benefits. After we'd done the comparison, we went on to the optimizing stage. In this case, there were no code changes needed, and this system can also handle some downtime because it's asynchronous. So we felt like there was low risk, and we could immediately go ahead with the switchover. We'd already tested the correctness in the comparison phase. We were confident in the correctness. Now we're in the optimizing phase. We no longer need to worry about correctness. And because we don't need to worry about the optimization here, we immediately did the switchover. And the optimizing phase was maybe a day or two. Basically, a deploy with the new configuration connecting to the new database. Then we went into the waiting phase. In this case, we also weren't super worried, but we wanted to make sure that we could roll back if necessary. So we waited for 2 weeks to see if the new database had any problems. And after 2 weeks, when there are no issues, we cleaned up everything, deleted all the old code, and got rid of the old machines. Yeah, as I said, this project was supposed to be relatively small and ended up taking longer. And the benefits were no longer enough to justify the project. And we didn't recognize that this was actually a migration until quite late in the project. So that's my first example. And the second example is something I've called a database migration here. This is a project that we knew was going to be large, but we needed to do it anyway. And it ended up it still took a little bit longer than we had estimated, of course, but I still think it went surprisingly well. And I think that this project happened after the first project, and I think that this framework also helped me make sense of it. So this is a critical service that gets tens of thousands of requests per second, which each fan out by an order of magnitude in the database. And we had a couple of problems. So we had MySQL. Oh, yes, I should explain what the system does first. So this system consumes something called rule sets from Kafka, which is a queue, stores them in MySQL, and then exposes decisions based on the rule sets for tracks, SoundCloud tracks. And we had two problems with this setup. One was that MySQL was approaching the max number of queries per second that we could support. This is a mix of a technical and organizational limitation, because we don't really do MySQL with sharding at SoundCloud. Another problem was that MySQL writes were too slow. So when we had batches of updates, they would get delayed because queues would build up because MySQL was so slow in writing these rule sets, which meant that new releases wouldn't get out on time, and we would have trouble with really large queues in the team. This more generally is because the data model of the system is a bad fit for a relational database and a better fit for a key value store. Yeah, so this was the justification of this migration. We had a technical problem and a product problem that we needed to resolve somehow. But we weren't sure if Cassandra had fast enough latency with this data model in order to handle our requirements. But we still started the project and hoped that we could make it work. We started the writing by setting up a new Cassandra cluster. We consumed from the same Kafka queue, but in a separate component. So this means that MySQL and Cassandra are not linked in their writing, because at that moment, it wasn't important that they were in sync. So we set up the writing and also designed the new data model. Here we were changing the data model entirely. And yeah, we set up the writing. And then once we'd started writing, we wanted to compare. And then we needed to actually merge the writing so that Cassandra and MySQL were writing at the same time, Otherwise, because Cassandra was faster, it would speed ahead, and they would not be at the same, have the same data, and comparing it would not make any sense. So at this point, we merged the writing to be in the same component and happen at the same time. Then we started comparing. In this case, we started reading from in the read path that went to MySQL. We started also reading from Cassandra in the background, so immediately return the response. But in the background, also read from Cassandra, compare the results, and log and instrument it. We immediately found some errors in how we wrote to Cassandra, which we fixed and then ran again. Then we found that there were some tracks that were missing rule sets in Cassandra, but they were in MySQL. Some of these were because the tracks had been deleted, and some of them were because of an error in the upstream system that issues rule sets. Excuse me. And this was actually fun. This was because the MySQL database is older than the upstream system and the Kafka integration. This MySQL database is already a couple years old. And so there was stuff that was in MySQL that had actually never been in Kafka and had been delivered before that integration was set up, which I thought was pretty fun. And yeah, we decided that we determined that fixing the upstream was out of scope for the system, or for this project. The important part was getting the Cassandra system to the point we were already at with MySQL. So we wrote something that directly looked at the data in MySQL, converted it to the data model we had for Cassandra, and wrote it directly to Cassandra. Before, we hadn't done this because we wanted to make sure that Cassandra could get all the data it needed through the normal delivery method. But at this point, because that caused some problems, we decided that that wasn't actually as important anymore. After this backfill, we tested again, and at this point, we were at 100% correctness, which was really exciting. And there was a pretty fun exception. So there were 12 examples out of, I think, 6 million that didn't match. And I looked at all of them individually, and they were all because of, I guess, a kind of race condition, but the difference in the writing speed of MySQL and Cassandra. So this means that this track was requested at the same time that new updates were being written, and Cassandra had just finished writing, and MySQL was still writing, which is why it didn't line up. So it was actually really cool to see this like in timestamps. Yeah, but now we were confident in the correctness. So since we were confident in the correctness, we didn't need to worry about it anymore. We also didn't need to test it anymore. So at this point, we switched the writing back to being separate. So MySQL and Cassandra could write independently, and we could focus on Cassandra on its own. We didn't really need to worry about the comparison anymore. So at this point, we changed the read path to serve decisions either from Cassandra or MySQL behind a percentage-based rollout flag that was initially at 0, so everything would go to MySQL still. Then we rolled out traffic really slowly. This is a really critical system, so we were very careful here. We rolled out traffic until we saw problems. Then we tried to figure out what the problems were. Here, particularly latency was something we were worried about. And yeah, we iterated on that until we got to our requirements. We were a little bit nervous about Cassandra handling the load that we had, but we eventually found out that all of the problems were in our client code and not actually in Cassandra itself. And yeah, so we spent some time understanding Cassandra retry policies that are quite complicated and also badly named, and also finding code bottlenecks. And Cassandra itself could totally handle it. And eventually, we reached numbers that we could live with, which in this case was slightly higher latency than before for reading. But we felt that this was acceptable. because it's still not that slow, and also because the writing speed was an important requirement for us. So writing is faster. We no longer have queues building up. And reads are a little bit slower. And a surprising effect was that we got slightly fewer errors than before, which we hadn't really thought much about before. So after we'd optimized, we moved on to the waiting stage. So I've called the waiting stage one stage, but I think in some way it's also two. So first you need to wait until you can trust your new system without a backup. And then after that, you need to wait until you can remove the new system, which in the first example we saw was immediately. But in this case, this project started a year ago, and we're still in the waiting phase, and we still have MySQL running. But I think that's acceptable and a good decision in this case. So first, we waited until we could trust MySQL without Cassandra without MySQL as a backup, which included engineers on call needing to be a little bit more familiar with Cassandra operations for critical systems. We needed to set up all the alerting and backups and tooling that we needed. And we also were able to learn from 2 outages with Cassandra. After that, we were ready to trust Cassandra in production and trust it at 100% all the time, which has been the case for 4 to 6 months now. But because this MySQL database is old and important, it has been used for a lot of analytics and business purposes that are still hooked up to it. And right now, it's not a priority for us to change this just to get rid of this MySQL instance. So you can see how, depending on what your needs are and what your actual requirements are, you can make different kinds of decisions in the different phases. But we already cleaned up most of the old code. We're in a different stage than we were in the spring. And the way I see it, the migration is finished, and we have this MySQL running as an analytics tool, mostly. OK, so to sum up, I'll move back to the phases. To sum up, migration projects vary wildly, and making sense about details is not usually that easy. They can be very hard to predict, but in my experience, they do follow a general pattern. And I've created this approach in order to help you and help myself make sense of the needs and requirements in the different phases. So first, you need to justify your project and justify it better than you think, have really strong reasons, and be ready for things to change. Then you set up the writing. After that, you compare until you have the correctness that you need, which might not always be 100%, depending on what system it is. After that, you optimize until you're ready to handle the production traffic that you need to. And after that, you wait and clean up for as long as you need to. All right, thank you.